Hello, hello, hello. How you guys doing? I just started a stream. Everything seems to work. Yeah. So I did a little vacation. Mm, And now I'm back. I also have to work quite a bit. So I took some time and I got sick. I'm still a pretty bit sick. I had a sore throat and now I have like congestion on the ear cheeks area. But now it's way better, so I can go back to doing my usual stuff. So let me turn lo-fi generator for some chill music. I think it's not overtaking my. I think a little bit. Yeah. You can also just. Yeah. Perfect. Okay. Maybe I don't want to start with that. I want to start with. Can I do keep above others? Yes. Perfect. So maybe I want to start with monkey type because I kind of this is not monkey type. Okay. Want to start with that. Purchase TypeScript because that's what I was doing. Yeah. Um, Let me adjust my table. It's shaking quite a bit. Is okay. It's more stable now. Okay. Link to another test. Let me do maybe some. Oh, Haskell is. Oh, I see. Maybe it's interesting. I mean, I never did some serious Haskell programming because I think the language is very complicated to do serious stuff. Like I can't wrap my mind around the functional Haskell functional paradigm. Although I also use a lot of functional patterns. Pretty decent. I mean, if there are no symbols, I can type really fast. Because you don't have to press the shift key. Interesting. My progress, yeah, I kind of forgot about it for quite a while, but I want to get back to it because I think it's fun to practice. Let me try some. I think it's called. What is it called here? Quote. Yeah. Is this on the correct layout. Oh yeah, it is. Okay, I think that's enough. Gonna warm up. So I kinda want to search for some architectural paradigms with the with different renderers, especially software renderers. So I want to focus on on the AI, not AI. I mean, I'm gonna use LLMs to search for this because I think it's way more convenient than trying to group things on that I find on Google. But I want to search it. I want to search how the different types. So let me go to Claude and I want to ask it. To make a software renderer for my own library, but I don't know how to. I don't know the different architectures you can add on it. I also want to make it possible to integrate on a GPU runner in the future. I only saw the Pyro library, but I want to explore other possibilities. Let me toggle. I mean, if I toggle search, I mean, I'm gonna toggle search, but I think it's going to take very long. Because it will basically crawl the internet for it. And meanwhile, I'm gonna search for no, I click on the ad by accident. Input. Yeah, I want to do mainly software at the moment. Okay, it asks. Region. Okay, it's going to search stuff, so I can also search some stuff like let me see this. Advanced 2D rasterization on modern CPUs. Is this the full paper? Oh, nice. Just gonna open here. Please. I don't want to use the browser for opening PDFs. Let me have this. Nice. Okay. Advanced 2D rasterization on modern CPUs. The graphics processing unit GPU has become part of our everyday life through desktop computers and portable devices. Because of the dedicated hardware, visualization has been significantly accelerated, and today's software uses only the GPU for rasterization. Besides the graphical devices, the central processing unit has also made remarkable progress. Multi-core architectures and new instruction sets have appeared. This paper aims to investigate how to effectuate multi-core architecture, can be applied in the two-dimensional rasterization process and what the benefits and bottlenecks of this rendering model are. We answer the question of whether it would be possible to design software rendering engine to meet the requirements of today's computer games. Interesting. So it's saying a lot of stuff on the article says a lot of stuff like how I think it's also explaining a lot of the evolution. So I know about SIMD, which is single instruction multiple data. The CPU has some of the instructions, and I want to explore these instructions on x86, x86. Yes. And yeah, mainly the SSE 2.1. So people, if you guys don't know, SSE 2.1 is the version that introduced SIMD for integer types, although you can also do with floating points as well. So yeah, this extended support mode for packet double precision floating point. Maybe it's also for integers before. Oh yeah, it was. But I think you can do this SSA2 is very, very, very old. Like, I think it would run. I think it's a requirement for the Vista. And introduced firstly on the Pentium 4, and the Pentium 4 is 1995. Oh no, actually, wait, 2000. Okay. The Pentium 4 was made on the 2000, so it's very safe that all the processors today can run these SIMD instructions. And because the SSC was made for processing vector calculations, it will be perfect for the rasterizer. So we might write some assembly. Maybe not even compiling intrinsics, like just full-blown assembly procedures. Because I kind of want to be FFmpeg. Yeah. And also there's this one is more recent, AVX2, and the AVX2 is supported to Intel as well. It doesn't say here, but the first support for consumer devices was Haswell, which is 2013, 12 years ago. So it might not run on all the devices, but most devices would run these. So yeah, and also ARM has Neo, which is their SIMD extension. So you can work with for 32-bit integers and also for 32-bit floating points. So it's 128 bit wide registers. Yeah, we can also work with ARM. Although I don't have an ARM PC at the moment. Maybe I can buy Raspberry Pi later. So yeah, is it done? Okay, search everything took like 7 minutes and 40 seconds. Now it's writing the report. I mean, it just scanned a lot of stuff. I only looked for Cairo render because it's the only render in mind that is written in C, and I think it's also used on the GTK toolkit. Okay, so Float search a lot of stuff for us. Yeah. This paper, let me skim through this paper a little bit more. These units are no longer suitable. Insane. Instruction set. I think this is writing on a very game dev perspective. Yeah, operating system routines like GDI which is, I think I'm going to explore it later, how to use GGI, but I'm gonna use Wine to test it, which will be enough. I mean, Wine is really good project. Like, can reliably test the Windows compatibility on Linux with your software. So yeah, it has some edge cases, but overall it's really solid project. I really like Wine. Mhm. I mean, Mesa is really good, but if you're referring to like NV, it's also 2014. So at that time it was really crappy because there was NVIDIA drivers were basically proprietary, but then they open source their user space modules, which made stuff better, and now we have a project that implements a Vulkan implementation for NVIDIA GPUs. So we have NVK, which I think it is part of the Mesa project. So things got better. Things got better. Can I get to the part on some of the techniques? Mm. Simple one driver rasterizer. I think it's okay. Let me go back to this. I mean, we can optimize these with partial partial drawing, so we can just specify a region that was damaged or dirty, and we send it to redraw that only that region, so we can save a lot of cycles instead of redrawing the entire window, which is also what a lot of these GUI toolkits do, like GTK and Qt. I think Qt does that. I'm pretty sure. GTK, uh, I know that GTK does that, and also Android. Images and objects using 2D algorithms. Yeah, I want to use RGBA. So it will support transparency. Mm-hmm. Mm-hmm. So it also needs to be parallel. I mean, I also expected that. I think a lot of the work can be parallelized on the renderer, but I don't know how. But, so I want to see it. I mean, yeah, tile-based rendering. You can separate the frame into tiles and have each thread work on the style. Wait, I kind of lost it. Oh yeah, I was reading this. Okay. Okay, so this paper is discussing the challenges at the moment. Now I think it's going to talk about the rendering model. I mean, we can also inspire what the GPU does and try to translate into the CPU, because the GPU is also absurdly. The GPU is an absurdly parallel device, so if we can transfer the knowledge on how the GPU can be insanely parallel and adapt it to the CPU, maybe we can uh, get some good performance on that. So, okay, so this seems to be the pipeline. We feed the geometry for the main memory, apply transformation, calling clipping, push texture to render queue, blah blah blah, and then the rasterization here. We have the number of threads working, and then we send when we are done, we send the frame buffer to the GPU to display. Also talking about textures, which is something I want to support because I want to display images. So yeah. I want to make a really competent renderer so I can be done with it. And work on other stuff like the programming language or the DSL for uh, defining the UI and state management. Yeah, we have a lot of overlapping objects. Mhm. Okay, these are talking about some techniques. I mean, only two are very nice. I want to assign the tasks and another to wait for them to be done. And there are the tasks they tested using OpenGL. Mm-hmm. Frame 1714 FPS without sending the frame buffer to the GPU. Yeah, I expect it to have some performance penalties. Because you basically have to stream the memory data to the GPU every time you want to write it. But that's the price you need to pay to have a renderer that runs on basically anything. maybe even on ESP32 or another microcontroller like the Raspberry Pi Pico. So yeah. Ooh, one thread. I mean, 800 by 600. I mean, it's good for a 2D game style. Yeah. Interesting. So might be on par. I mean, GPU always going to crush it, but the difference is not that high. Yeah, I mean, it's interesting. Interesting article I've read. What time it is? Windows on top. Oh well. Okay. Let's see what Claude has to offer here. Let me download this as PDF. And open it. I think I've opened the wrong file here. Yeah. What Claude has to offer us with this paper? Yeah, research it did. The optional architecture for Rhino combines covered page scanline rasterization on CPU with Nano VG style function pointer backend abstraction. What is Nano VG? Oh, it's a library for vector graphics rendering API. I see. I see. And what is coverage-based scanline rasterization? Oh. Okay, maybe it's going to tell us more here. Process polygons row by row using edge tables, a global edge table scores all polygon edges sorted by minimal y coordinate, while an active edge list contains edge intersecting the current scan line. So it recommends to start with scanline, then to consider edge function blocks within tiles or critical paths. Yeah. Microseconds frame time, so yeah. This is really good. The rectangle tracking, layout caching, and glyph atlas caching. Then there is the memory layout. Okay, it's AOS versus SOA discussion and AOSOA. Now I want to use SOA because it's the SIMD friendly style of doing operations. So yeah. mean, I'm doing some the I'm writing the custom allocators to do the alignment stuff. So yeah. So HOA for edge tables. Align buffers to 16 bytes or 32 bytes. Use arena allocators. Use pool allocators. Yeah, I already have an arena allocator implementation, so that's cool. Size, tile buffers, draw, and one cache. Okay. Covers based. Excellent. No memory. Around one time memory. Yeah. Excellent quality. For vector graphics. I see. Calculates the exact geometric area each primitive covers within each pixel. Oh yeah. I think I'm going to do something like this. We just make a huge struct, and then we set and then we have just a bunch of function pointers. It will work as a function pointer table. So we can implement the the stuff pretty easily. And it has Skia because almost a lot of stuff uses Skia, like Chrome, Android, and Flutter. So yeah, a lot. And also we can count .NET MAUI because .NET MAUI on Linux and the app uses Avalonia UI, which also uses Skia behind the scenes. So yeah, and I think the Labor browser also uses Skia. But yeah, anyways, a lot of projects uses Skia. But I want to make my own with C. Analytic XGLising. I don't think I'm using ES 2.0. I mean, we can do, but I think it's old, very old. I mean, we can see it's not hard. I mean, I don't want to support like very old drawing APIs because the software render will exist for older platforms, but we'll see. Maybe if someone really wants and implements it for me, sure, we can have it. Performance techniques for fast paths, for aligned rectangles, SK picture, records commands for display list optimization, lazy resource allocation, GPU draw batching by state. And then there is Blend 2D, the state of the art in the software 2D rendering. What the hell is Blend 2D? The engine utilizes a built-in JIT compiler. So it JITs all the operations. Yeah. Oh, and it has a C API despite being written in C++. Nice. Okay, interesting. So uses runtime JIT compilation of rendering pipelines. I don't know if I need this. I think I won't. I mean, I just want to make a simple one, so it doesn't solve. I mean, it talked about a lot of strategies for rendering. But maybe that's not what I wanted. I wanted more how to architecture, like how do I I mean, maybe it's what I searching for, but I don't know. Paths, beziers, veils, strokes, transforms, clipping, solid colors, and then the deferrable gradients, blend modes, dash strokes, Image, texture fields, rounded rectangles, and texts. Yeah, rounded rectangles can be built from Bezier paths. Excessive virtual function calls. I mean, I don't want to also write it on. It's not entirely C89. It's like C89 with some C99 aspects because some of the behavior on C89 is not defined and they are only defined on C99, and a lot of compilers, even when they are compiling on C89 for memory behavior, they rely on C99. So yeah, so it's like a mixture of both because C89 has some bugs on it. I mean, why it's doing OpenGL? Don't care about GLES at the moment. Okay. Also, I think nuclear does something like this. Oh, it's searching stuff again. Oh well. It's thinking. It's generating another file. But it's so awkward on this little window. Mm-hmm. Replay to multiple backends. Mm-hmm. Yeah. Maybe I want to do the render to output an image instead of the window, because it will be easier to debug, I think. Oh. Yeah, I want to separate the drawing API at the backend. Because drawing seems to be a very complex stuff, so I want to make it all behind an API and not worry about it again. Or at least only worry a little on the future. So yeah, I want to really solve the rendering problem. Mm-hmm. Okay, so we have basically we have a list of commands. It starts the commands, and then we record these commands, and then we create the then we send it to the renderer, and it will render the stuff on it. Mm-hmm. Okay, what time is it right now? 10 a.m. I have some time. The string, what is Uh, an hour and 20? Okay. So I think it's trying to focus a lot on immediate mode, despite me wanting to implement a mainly retain mode system. So yeah, picture currently maintains call rectangle, approximately blah blah blah, right side. I mean, there will be overhead instead of emitting draw calls immediately, but it should pay off, especially on slow hardware. Start with brief perfect buffers, just simple sufficient for GUI rendering. Yeah. Mm-hmm. It's going. Yeah, maybe we can start doing some uh rendering stuff. So yeah, let me start doing something about it. We created a document. Yeah, linear gradient, radial gradient, paint. Yeah. Mm-hmm. Stroke, fill path, stroke path, transform, flip path. Mm-hmm. Command buffers. Okay. Mm-hmm. Yeah, is the this feels solid to start the function pointers. Because I mean, functions are also just addresses. Actually, I think we can go way higher because I think there is this cool UI layout library, and this is, I think, on. I mean, it's now using the HTML stuff, but I think we can enable the canvas renderings, and now it's rendering everything on canvas. I mean, the text is kinda but the HTML is better for text, but it is it is nice, and also have like this little bug window. Yeah, it is very. It feels very complex. And also it tags if it's off screen or not. Yeah. and I think it's really fast. I mean, it's only a layout library, but I think it can recompute layout really fast. Maybe it says on the GitHub. This is a really cool project. The main problem is that it is for immediate mode, and I don't want to do immediate mode. I want to do retain mode. Kind of retain mode kind of API. I mean, has a retain mode rendering. But yeah, I mean, it also depends on having, it does implement rendering, it just implement layout. Rendering is a whole other beast. Layout is also very complex, but I don't think it's that expensive. I mean, it can be, but I don't think it's very expensive if you do properly, like this library is doing. So yeah. So I opened this by accident. Let me implement a simple software renderer. So I think I want to, let me do some comment. So actually, let me consult here. Oh, what to do first? What operations do I need to do first? Implement first. And it's going to give me a roadmap. I mean, we can implement a rectangle. I think it's the easiest. And then a circle. The circle is somewhat complex, but also it's basically testing if the pixel, if a pixel is contained within the circle. If it is, draw the pixel. Otherwise, does not. Oh, I see. It's paths. Okay, paths are a whole other stuff. Oops. Then command buffered. Let's see. So basically, we just do the operations inside the the buffer. So okay. And then we work on, the hellos with lines and curves. Then we do command buffers. Then we do transform stack to apply scaling and rotation on these. And then curves. We add Bezier curves, strokes, and then the OpenGL backend. Polish, anti-aliasing, gradients, clipping, and text. With this library, I think this library is good. Yeah, we can use this library. Gradient, anti-aliasing, clipping paths, blend modes, text rendering. It is very complicated. Okay, so let me actually start a new. Let me actually not do some work on the library. I want to let me do some working on a simple renderer. So I think it's this. Yeah. So let me do some stuff with it. Let me ask it what I want to test it by outputting a simple image. What image format is very simple that I can open with an image viewer? I think there are some very simple image format libraries, image formats that you just output the entire memory buffer into it. And oh yeah, ppm. We just write on a ppm file, which is only this. It only has this header. I think it opens on my system. Linux supports, I think I can open simple ppm files, so yeah. So I'm gonna do this. So gonna do width and height, and then we are gonna do and we are going to allocate the the amount of bytes. So both data will be equal to malloc, and then we are going to calculate the width with the height and the size of since the it's just going to be width and height because it will be one byte, but we can just put char here. And then also, yeah, like this. So finally, and then we just do write buffer, write binary. We'll also include file. Oh, it's a pointer also. Then we just going up. Oh, it's just extracting the pixel data. Oh yeah. Actually, wait. ARGB. Oh, it's actually big. Oh, no. It's not size of chart. Exactly. Every component has. Let's do 4. Because the pixel, it's actually 32. 32 bits, so 4 bytes. So and we can also just do this. I think we can actually. I think it needs to be a pointer. Yeah. Then we need to so we are on RGB, but if you see here the R, it's on the order. I mean, yeah, maybe well, yeah, the R is actually what's first is the A, but we are going to skip the A. So basically we are going to do this operation, which will mask the. We are going to do a bit shift and then and the values. I don't know why the end part is necessary. I don't know. I think it's redundant. But then this is going to be for the other byte. And B is going, you won't have this calculation here. And then we just do output C R G B. Then we close it and then return 0. We also need to test for errors here. So let me create a buffer. So we're gonna create 800 by 600. Oh yeah, we also need to write the. We also need to write the header format. So it's gonna be p6. Yeah, we're gonna write the header and then just output the pixels. Buff width, buff height, and then we do buffer alloc, we allocate, and then we do we also can do memset buff data. But size n. Oh, the first is the pointer, then the size is last. Okay. Oh yeah. But semicolon, I don't think we need this. Why does this is erroring? Oh yeah, it's not. What header is this? Oh, string. Then buffer, right, ppm buff, and then we're going to output yeah, some simple tests. Okay, so we can go to this simple renderer and then go GCC LC main.c output simple render, and then we can execute simple renderer and it's segfault. Nice. Okay, why it segfaulted? Oh, I know why. Wait a minute. Let me do these things correctly. Now it works, so we can it output the output.ppm, and because we set up all pixels to be the max value, it should be white. So create a yeah, it is white. What I have let me search for a actually. Oh, I don't have sudo. Yeah, that's for obvious reasons. Yeah, here, open with. I mean, we can see here it outputted uh, a white image, and if we set it to 0 here on 128, it should output. Let me open Dolphin on a different window. It should output gray. It outputted a gray tone, and if we do 0, it will be black. Yeah, perfect. So the PPM image format is very simple to use, so we can just output the format directly. Okay. So okay, so I'm going to do now. I want to write buffer draw rect. So I basically want to draw a rectangle to the buffer. So we need 13 width, height, and then RGB. Now, width and height RGB. Okay. I mean, I think I'm going X and Y. XY width and height. ARGB. And it's going to be color. So basically I want to do and also I want to draw a rectangle. Let's draw a white rectangle on the top of the screen, having 100 by 100. So it will basically be a square. So can I do this? Zero, y 0, 100, y 100, and it's Thomas. Right. We can. Why can't I just cast a number? Okay, I'm gonna do the color. A will be and then R G E. So I want to draw a white rectangle. So basically what we are going to do is for I 0 I width and height. I mean, wait, is this correct? Because we're just, oh no, we are iterating. Oh, because the array it's a 32. It's correct. It's correct. So we are going to test if the, so we're going to calculate the, we need to calculate the bounding, whatever the rectangle, the pixel is inside the rectangle. So if so going to the pixel, no, Actually, let me do a better way. So we are going to iterate with height. I mean, it is actually y. We are going to iterate y, and then we are going to iterate width. So x. Going to iterate x. Going to iterate y. Then going to iterate x. And then this is going to be way simpler if we do like this. So if x is it greater or equal than rect x, let me actually inside x. If it's inside rect s and x is less or equal than plus width, and then inside y will be the same thing. Basically, we just place this with height. So we're going to test if inside x and inside y we are going to basically data xy equals will be equal to I mean it's actually plus y times of height, I think. I mean, I think we can just cast it to a number, no? Please. Why it's so complicated? This is literally the size of yeah, this literally has 32 bits. Do I need to do oops, do I need to do something like void pointer and then u 32? Okay, let me search this. Gas struct to integer. Okay. So we need to get the address. Okay. Okay. I think that's it. Let me see. Uh, what? What have I done wrong? Okay. I just want to draw a single rectangle, not this. Is this on the same line? No, they aren't. What? Okay, mixed up. Okay, they are. It is funky. It is funky. It's not a solid rectangle. Okay, it's inside X and it's inside Y. What have I done wrong? Maybe I messed up the... No, I don't think I've messed up. I don't think I've messed up this. Because we are offsetting the X with the Y coordinate. So it should work. I think it's inside the test. So if X is greater or equal than rect X, and X is less or equal than rect S plus rect width. So basically, if rect is 0 and X is 0, it will fill this. So X greater than 0, we will always fill this, or will accomplish this. And X, I mean, it might be this. It can only be this. Because this is correct. It tests if it's inside X and if it's inside Y. I think I'm fucking up with this. But I mean, it should work. It should work. right? Oh no, I think we need to, it is the width, because we need to offset the width, not the height. Actually, yeah, we have to offset with the width in this case. So yeah, if we open this on GIMP, we can see a little white rectangle on the top. So okay, so let me change some stuff. Let offset to 200, like 300 and 400, and be an actual rectangle. And let me do, I want to test the color, so I want to generate a red rectangle, and it should be a red. Yeah. Okay, this is what I was thinking about. Wait, but it's not even. Oh, I know why. It's this. That's exactly what I was thinking about. It's the byte ordering. Look, so because we are using a little endian machine, this order is not ARGB, it's BGRA. So if we basically do this, like B, G, R, and A, look what happens. It's red. Yeah. So basically changing the, because we are on a little endian architecture and we are casting like this directly, this is technically undefined behavior because you don't know the what order the bytes are. So for example, on a little endian machine, RGBA is actually ARGB. ARGB is actually BGRA, and on big endian machines, it's actually ARGB. So if we run this on a PowerPC platform, it would also output a cyan rectangle because of the byte order. So what we actually want to do is to maybe we want to extract, because I want to have this order of structure. Why don't I? So basically what we need to do is this. Let me go to here. Oh yeah. Let me go inside here. So pixel. So we can end this. I think we can do this because we are basically ending with itself, but modifying the color. So I think it runs this expression first, and then we'll end with pixel itself. So no, it doesn't work. Why? Why it don't work? Why not work? It's also here's 24. Okay, maybe ending this. Do I don't think R is correct. Yeah, it's not. Yeah, it's not writing correctly to the buffer. Okay, so to write, if we want to write the we want to write the correct color, I think red is 00FF0000. They should be red. Yeah. Because despite this being on, this not being like proper little ending order, I think the compiler converts it automatically, but not with structs. Structs represent the not with structs. Yeah. So what's going wrong? Okay, I bit shift this to be a bit shift this to be I need to bit shift this to get the... Maybe... Hmm. Maybe we can do... I think this works. Yeah, this works. This works because we are basically bit shifting. We are okay, let me explain this properly. So this works because we are getting the max value. We are bit end with the color of the pixel. Oh no, I know why this works. Okay, and this also doesn't work. Forget about it. Because I forgot this part. But this should work. And it doesn't. Why it doesn't work? Maybe because the pixel is black. Actually, we can just add to it because we are... No? Why we can't just add to it? No, we can't add to it. Actually, maybe there is a simpler way. We can add the different pixel. No, okay. This is confusing for me, for my little brain. Why doesn't this work? Yeah, this doesn't work at all. Why? Why though? Am I dumb? Maybe I am. So ARGB, and we are reassigning again, but it seems to not work. Wait, is this? Oh, I mean, It should not have a difference. There is. Okay, it doesn't. But I think we need to cast. We need to cast it with a big number. No, it's not a casting problem. I mean, it should work because we are basically we're simply adding the R and then the G and then the B. I mean, I can just remove this because this literally doesn't matter at the current context. Let me comment this. So R by bit shift to be if I cast. Oh, it doesn't work. Why this doesn't work? But if I do this, it does work. Because I think. Oh wait. Wait. Yeah. I wonder why it didn't work. It's this order. But why when we are writing we do this? Okay. What time is it? Okay, 11. It's quite some time we are spending drawing a rectangle on a image. But I want to make it or make a solid foundation on how to draw stuff. So we can draw stuff like this, but we are also extracting the component like this, and I want to. We are extracting it like this. How can I don't want to have an add operation. I want to do basically if I do an XOR of this, actually let me test it. If I do an XOR of this and AND, no, it doesn't work. Okay, think I'm kind of... I worked. This method worked, but I think it's not the most efficient stuff. So I'm gonna consult what Glow did. So I think he did some... Yeah. Let me just output the... Let me ask this as more specific question. So if I... Let me ask him this. Yeah, we need to pack it. Don't need to do the... Oh, we... Yeah. Yeah. Let me... I forgot about it. So basically we can just... Uh, so I'm gonna define as... Mm-hmm. Then we can do basically this, and it should work the same. Yeah, it works the same. Okay. So we can extract the pixel color like this, which is nice. And yeah, I can just do it like this, and yeah. So actually, let me RGB. And start defining this. And it should work the same. Yeah, it works the same. Yes, okay. Very nice. Really cool. And then gonna draw. So I can just, instead of instantiating arm like this, and then right X. And then I want another asylum like this. I mean, we can make it bigger. Yeah, like this. Beautiful. So we can draw rectangles. And if I draw it like this, it will overlap. Mm-hmm. Yeah, very cool. So we made a simple buffer rectangle renderer, which is, I think it's pretty cool. I mean, it's a small step, but it is a important step to begin with. So maybe what I can improve is I can close this to be an expression. Okay. Nice. Okay, so I think uh, I spent quite some time. 248. Yeah, it is a considerable amount of time. I think we evolved quite a lot. So yeah, next time I think we're going to start doing some more advanced stuff. I think I want to actually let me screen this so I can use this scroll bar. So I want to start to do pathing. And we can move on to more complex stuff. Mm-hmm. Yeah. Yeah, I think we if we implement the basic stuff, so direct, if we implement paths and transforms, curves, strokes, we can basically advance quite a lot on the renderer. So yeah, next stream I don't know when I'm going to make. I also want to make like some video formats, like short video formats, elaborating on my progress on the library, on what I'm learning and the library, because there is a shortage on content on YouTube, and I think it would be very interesting to share with people. So, okay. Thank you everyone for watching the stream. I hope you guys have a nice day.